All right, another, probably the last in my video homework tutorials about drawing molecular orbitals. This molecule is allene, and I haven't shown the H's, so this is not, it's kind of a hard molecule to draw in line form, because it would look like this. That's hard to interpret, isn't it? So I've drawn C's in explicitly, and I want you to do two things. So this molecule is called allene, if you want to Google it up on the side. I want you to draw the pi molecular orbitals, and I want you to tell me where the hydrogens are. So just the pi molecular orbitals. All right, go ahead and hit pause and go away, do that and come back. Okay. I have a feeling you guys aren't really pausing. You should pause. Hit pause and actually work on this. Could just be that I'm paranoid standing in my vacant office by myself. All right, so again, what do you have? What's the hybridization of these atoms? This carbon, the first carbon, got to have two other things not shown, right? There's got to be two hydrogens there. It's got one pi bond, double bonded to one carbon. So the hybridization of the left carbon will be sp2. Right carbon is the same thing. Two hydrogens, which will be single bonded, and then one double bond. So one double bond again will be a sigma bond and a pi bond. But the carbon in the middle, there are no more hydrogens. 4 bonds are shown to it, right? 1, 2, 3, 4. So 4 bonds are shown to carbon. It's got 2 double bonds. 2 double bonds, so it's got to have one sigma bond here and one sigma bond there. Again, every carbon, any 2 carbons bonded to one another in an organic molecule will have at least one sigma bond. Well, they'll have one sigma bond. Can't have more than one sigma bond, you have to have at least one sigma bond. 2 pi bonds. 2 pi bonds means you're sp hybridized. So that middle carbon is an sp carbon. All right, so you actually have to answer these questions in the order given. You can't just put the hydrogens in. I mean, obviously 2 hydrogens here, 2 hydrogens there, right? All right, I'm going to erase the hybridization. Maybe I'll write the hybridization in. I'm going to erase the hybridization. I'm going to put the hybridization on top here. Okay, so down below, let's start with this carbon. And if you haven't watched the video on ethylene, go do that now. Hit pause, hit stop, go watch the ethylene video. All right, so the carbon, the sp2 carbon, I'm drawing this canted just a bit, but there's basically an sp2 orbital going away, an sp2 orbital coming out at you, and then an sp orbital in the plane. Okay, hydrogen here, hydrogen here. And then, middle carbon, it's going to have an sp orbital. What's the geometry of an sp hybridized carbon? What's the geometry of that carbon? It's linear. So, sp orbitals like so. Alright, there's our sigma bond, and again, you've got an sp2 hybridized orbital over here, and I'm not going to draw anything in on that one yet. Okay, I'm going to hold off on drawing anything else on this carbon over here. So, sigma bond, there we go. So, what about the pi bond, this first pi bond? Well, again, if you watch the ethylene video, the p orbital in an sp2 hybridized carbon is going to be orthogonal to the 3 sp2 orbitals, right? The 3 sp2 orbitals are going to be, an sp2 carbon is trigonal planar, the 3 sp2 orbitals are coplanar, and I've drawn them as sort of being in a plane orthogonal to the board. That means the p orbital has to be in the board. All right, for this to be a pi bond, you have to get a pi bond here, so pi bond. Okie doke. Well, you're well on your way. You've drawn a pi bond between an sp2 hybridized orbital carbon and an sp hybridized carbon. So what about, I'm going to erase these sigmas. I'm going to assume you guys know what the sigma bond is. All right, there's a pi bond now between the carbon in the middle, the sp hybridized carbon, and the right sp2. There's another pi bond here. Where is it? Well, this orbital that I've drawn, the p orbital I've drawn, can't be involved. It's involved already in a pi bond. You can't use one orbital in two bonds, one single atomic orbital in two bonds. Likewise, it's sp. There are going to be two pi bonds. There are two p orbitals on that atom. This carbon has two p orbitals. Well, where are they? Again, make everything sort of space it out as much as you can. So if there's one p orbital here in the plane of the board, and there's a bond, a sigma bond in the plane of the board, so we sort of basically have a y-axis and an x-axis. The second p orbital is going to be in the z-axis. So it will, again, I apologize for the art. The second p orbital is basically pointed straight out at you. Like, really, it's a cylinder. Let's see if I have anything. Right, second p orbital is basically like that. It's got lobes, and imagine it actually went back into the board. Okay. So then, for this blue second p orbital on the sp hybridized carbon to make a pi bond, where does the p orbital on the rightmost carbon have to go? Well, it's got to be in the same plane. It's got to line up exactly with it. There's our second pi bond. All right. So the second pi bond in allene, counting from the left, is actually orthogonal to the first pi bond. These two pi bonds don't overlap. If you watch the allyl cation video, right, we had three pi orbitals, p orbitals all overlap to form one pi system. These are actually two separate pi systems. They don't overlap at all. Okay, then where do the hydrogens go for carbon, for this carbon? Well, if you look at the sp2 hybridized carbon on the left, the sp2 orbitals are orthogonal to the p orbital. So that means the sp2 orbitals on this carbon have to be orthogonal to this p orbital. Well, the one in the middle is, and then to get that further, what you would have to do, and this is going to get really messy, I think. So this is in the plane, and that's in the plane, and I'm drawing them a lot longer than they should be. So these are sp2, sp2, and this guy is p. And the middle one here is sp2. All right, and then you have a hydrogen, 1s overlap with that. So if you look at this, the two hydrogens on the right are in the plane of the board. The two hydrogens on the left are orthogonal to the plane of the board. So if you want to draw this on allene, and I'm going to erase all this artwork I put on allene. If you want to put the hydrogens here, these will be in the plane, and then you'll have one back and one out. Make sense? So you should work through this. You should be able to figure out, like, starting at one position. Again, as I've set up with a lot of this stuff, where you start is arbitrary. Where you finish is very important. So once I put this p orbital in the plane of the board, that tells me the next p orbital that is involved in the pi bond of that carbon has to be in the plane of the board. The next pi bond then has to be orthogonal. Okay, so this is the molecular orbital system. I'm not going to draw another allene. All right, so this is a follow-up. I'm not actually going to answer this on this video. I will at some point. But ask yourself, is that allene chiral? Go away and figure that out. I'll take that up in another video.